So given the parametric equation of a curve, what can we say about the curve? Well, we can start by plotting some points as we did when we initially started graphing for functions of x. We take some values of t and plot the points. So here we have a curve described by the parametric equations x equals t cubed minus t, y equals t squared, and the t rounds from 0 to infinity. So if we plot 5 points on the curve, say corresponding to t equals 0, 0 0.5, 1, 1.5, and 2, we get the points listed here. And when we plot these points, the point where t equals 0 is the point 0, 0. Here we have the point where t equals 0.5. Here we have the point where t equals 1. Here we have the point where t equals 1.5. And here we have the point where t equals 2. Now, when we started graphing functions, we plotted some points on the graph and then we joined the dots. And we can do that here, and we seem to get a curve that starts at the origin, moves upward to the left of the y-axis, then goes back to the y-axis, and then heads off into the first quadrant with y increasing and x increasing. Now, of course, our graphing techniques became much more sophisticated in Calculus 1 when we studied calculus, and we can also use those graphing techniques to figure out what's happening here. So x is a function of t and y is a function of t, so the derivative of x with respect to t should tell us where x is decreasing and where it's increasing, where it has a maximum, where it has a minimum, and likewise the derivative of y with respect to t should give us a lot of information about how the y values are behaving on the curve. So we have a rough sketch of the graph. We'd like to know precisely perhaps where this graph turns, where the x value is at a minimum, and if the trend continues, if the y keeps increasing and the x keeps increasing, or does the curve turn around somewhere outside the window in which we've drawn. I claim first of all that x and y are always increasing for t bigger than or equal to 2, and the curve cannot turn around again. It can't turn downwards, nor can it turn backwards. The derivative of x with respect to t is 3t squared minus 1, and we know that this is equal to 0 when t is plus or minus 1 over the square root of 3. X prime of 1 is equal to 2, which is greater than 0, and we could check that x prime of 1 over 4 is going to be less than 0. The x values are going to be decreasing until t reaches 1 over the square root of 3, and then they're going to be increasing from there on in. So the x values continue to increase when x is larger than 1 over the square root of 3, and likewise the derivative of y with respect to t is 2t, which is always positive, and this means that the y values are always increasing. So we see this increasing trend continues. Our graph will not turn outside of the window we've shown, and in fact we can pinpoint precisely where this turning point that we've already drawn on the graph is. And this happens when t is 1 over the square root of 3, because at that point x of t reaches a minimum, and this is exactly the point where this turn happens on our graph. So there is exactly one turning point on our curve. And let's look at the graph of this curve on Mathematica. We start with the initial point at 0, 0, and as t increases, we see the y increases, the x decreases for a little bit, and then it starts to increase, and then our curve continues to increase in both x and y.